Welcome to the AI Checkpoints. Today we're plunging into a topic that's, well, foundational to nearly everything digital these days, information retrieval. It's really all about getting the right info to the right place, right? Whether that's for a huge AI model or just, your own search query.
That's exactly it. And today our mission is sort of unpack the R in our RAG Retrieval-Augmented Generation. We're looking at a really great exploration of this by Philipp Krenn over at Elastic. His presentation, Information Retrieval from the Ground Up, it's just packed with useful stuff.
Ah, excellent. Yeah, I saw that one. Okay, so let's get into it. I think many people assume search is super modern, but retrieval. This idea has been around for decades, hasn't it?
Oh, absolutely. Decades.
So our deep dive kicks off with the classic keyword search, or lexical search, I guess is the term.
Precisely. Think about how a system finds, say, these are not the droids you're looking for. The magic really starts with tokenization, just breaking the text into individual words or tokens.
Okay, breaking it down.
Yeah, and then usually stemming. That trims words down to their root. So looking just becomes look. And often stop words, common words like the, is, a, not. They get removed because they don't add much unique meaning for the search itself.
Right, they're just noise in that context.
Right.
But here's what I find really interesting. The search engine does most of this heavy lifting before I even type anything, right? At ingestion time.
Exactly. That's when they build the crucial piece, the inverted index.
Okay, the inverted index, walk us through that. What is it?
Think of it like a giant, meticulously organized index at the back of a massive textbook collection. It's basically an alphabetically sorted list of all the tokens, all those words we extracted, and for each word, it lists exactly which documents it appears in and where.
Ah, okay. So it knows precisely where droids is located ahead of time.
Precisely. It makes the actual retrieval incredibly fast because it's just looking up the word and grabbing the document list. It's, as Philipp Krenn puts it, kind of dumb but scalable.
Dumb but scalable. I like that. But it means it's literal, right? It doesn't know a droid means robot unless you explicitly tell it.
Exactly. It lacks that contextual understanding, which brings us nicely to the more modern approaches.
Yeah. So if keyword is about literal matches, where do these vector embeddings fit in? We hear about dense and sparse vectors. How do they get beyond just the words?
Okay, so this is where the machine learning really kicks in. Think of it like creating a map, a multi-dimensional map. Instead of just words, documents, or even parts of documents are represented as points, vectors in the space.
Like coordinates?
Kind of, yeah, coordinates based on meaning. So maybe related concepts are close together on this map. When you search, the system converts your query into a point on the map too and finds the document points that are nearest. It captures semantic meaning.
And the dense versus sparse thing?
Briefly, dense vectors use lots of dimensions, lots of numbers, to capture subtle nuances in meaning. Sparse vectors use fewer dimensions, often better for representing specific keywords or terms, more like a sophisticated version of keyword matching sometimes. Both are about plotting meaning.
That sounds, well, way smarter. Understanding context, not just words.
Yeah.
But I bet it's got its own quirks.
Oh, it definitely does. A big one is, unlike keyword search, which might say, sorry, no results, vector search always finds the closest match.
Always. Even if it's completely unrelated.
Well, closest in that vector space. It might be pretty far off in human terms. So the challenge shifts, It's less about finding a match and more about picking the right embedding model and figuring out if the matches it gives you are actually relevant. It can feel a bit opaque sometimes.
Right. Less clear cut than just did the word appear or not.
Yeah.
So if keyword has strengths for precision and vector for meaning, do we just mush them together?
Mush them together. Well, yes, essentially. That's hybrid search. You blend the results from different methods, keyword, dense vector, maybe sparse vector too, to try and get the best overall result.
Okay, but how do you combine results that are scored so differently?
Good question. Trying to normalize scores from totally different systems is really hard. A popular technique is reciprocal rank fusion, or RRF. Instead of looking at the absolute scores, RRF basically looks at the rank of a document in each result list. Documents that rank highly across multiple search methods get boosted. It's quite clever.
Interesting. So it's about consensus across methods, not the raw scores. Speaking of scores, how does something like keyword search even decide what's most relevant? Is there like a standard relevance score?
Not really standard, no, but there are well-established algorithms. BM25 is a very common one. It's sort of a refined version of an older idea called TF-IDF. BM25 looks at a few things. Term frequency, how often your search term appears in that document.
Okay, more mentions might mean more relevant.
Right. Then inverse document frequency, how rare is that term across all the documents? Rare terms are usually more significant.
Ah, so finding protocol droid is probably more important than finding the.
Exactly. And it also considers field length. Finding the term in a short title might be weighted higher than finding it buried in a long paragraph. But here's the really crucial bit Philipp Krenn emphasizes. Never treat these BM25 scores, or any search scores really, like percentages. Meaning a score of, say, 0.8 doesn't mean 80% relevant. It's just a number used to rank results for that specific query. You absolutely cannot compare a score from one search to a score from a different search. They're relative, not absolute.
Okay, that's a super important takeaway. Don't mistake the ranking score for some universal measure of relevance. So this brings up a big question then. What's the practical takeaway from all this for you, the listener?
I think the single biggest takeaway is that search is incredibly domain specific. There's no one-size-fits-all answer. What works brilliantly for an e-commerce site, where showing something vaguely related is better than nothing.
Right, like suggesting similar shoes.
Exactly. That same approach would be a disaster for, say, a legal research database where you need absolute precision, finding the specific case, not just related ones. It all comes down to your specific data, who your users are, and what they actually need to find. That context is everything. It's why information retrieval is still such a complex and, frankly, fascinating field.
Wow, yeah.
Yeah.
We've definitely gone on quite a journey today. From tokens and indexes, which feel almost mechanical, all the way to multidimensional meaning maps and hybrid strategies. It really shows how these complex systems are built up layer by layer. Some clever ideas in there.
Absolutely. And it's constantly evolving, isn't it? Blending that older established wisdom with the newer machine learning capabilities. So maybe something for you to think about is, how does understanding these mechanics, even just a little bit more, change how you think about finding information? Or maybe even how you'd build a system to help others find things?
Definitely something to mull over. Great stuff. Thank you for joining us on this deep dive.
My pleasure. See you next time.